I kind of want to get a lot done today. So we have an early start. I want for when we finish our little Wayland OpenGL application, I kind of want like something like nice to show off when we get there. So I'm kind of thinking I sound sleepy as fuck. No. This is normal. It's just it takes a second to get going, man. I think what I want is like something like the little monkey from Blender. Like if we just had like an app that could do this, essentially, that would be pretty cool. Pretty cool. So I think what I want to do is I want to like texture this thing, export it, write a quick and dirty OpenGL app that like imports an object, imports the texture, applies it, and then hopefully we can kind of like bang that out and have like the world's shittiest app that we can like use to demo when we do our final Wayland integration, like Wayland OpenGL integration. So I think step one is to color this guy in so he looks pretty, right? We want him to look a little pretty. So let's start there. I think we want to go shading. I think we want to give this guy a texture that comes from an image that we need to create. And then we need to color this guy in. So let's make him a little brown. Where's brown on here? Like kind of like that. Maybe a little darker. And then we'll color in his eyeballs. Do you have a CS degree? Computer engineering, which is close. Let's color in his eyeballs. So let's give him real white ass fucking eye whites. Saturation 0. And then where's my paintbrush? This one. So this is there and this is there. Okay, so let's just kind of like... And then we're kind of seeing through him a little bit. So let's kind of try to fix that. Doesn't have to be perfect. Just to be good enough. Just to be good enough. And then let's color in his pupils. He's gonna have black as fuck pupils. All right. So yeah, early today. Yeah, I have a lot I want to get done. That's good enough. Good enough. Let's make the world a little bit brighter. Is that how do I see what he looks like in the world? Here we go. This isn't changing anything. Got it. Yeah, that looks fine. And then I want to like bake this into a texture because our shitty OpenGL app that's going to show this guy is not going to have like any lighting model. I want to avoid that. And so what you can do is you can like take this and you can like take the world of lighting around him and like basically apply that to the texture. So I think like the way you do that is you like create a new texture and you say like, you like click on this. And then I think if you're using ray tracing, there's like a bake thing. Yeah. And I could be like, yo, just bake this motherfucker, bake his lighting into this picture. And we don't have to let him run the whole thing. I think I might cancel this early. So you can kind of see like, it's like a similar thing to what we drew, but he has like kind of like shadows attached to him. And I think that I just want to make sure that like, this looks okay. So maybe, and then I think that if I go back to non-ray traced and I hook this up as the color input now, and then I like disable our lights, turn the world to like black. I guess the world has to be kind of like, see, he's like uniformly lit according to the world. And if we turn off like all specular reflection, we kind of have like static reflections baked in this guy's head, which means that if we were to just render this image now, we kind of have like shadows so that when we're kind of navigating around, if we were just to like color this guy brown and use him in OpenGL directly, he would have like, it would just be like one color. We wouldn't see any of this like definition of edges. And so I think that if we just bake this like this, so you can see like there's no like specular reflection happening here. It's all kind of like baked in a thing. So I think we just want something almost like this. I think we probably just want like a few more lights so that it looks like a little more dynamic. I guess it doesn't matter. We're trying to get quick and dirty. So this is good enough. This is good enough that you can like see the fucking shape of the guy. I guess from the bottom you have like no definition. So maybe we do it again with one light underneath as well. One light underneath. Okay. So layout. Let's just kind of like drop a light down here. Maybe like another one over here. Like we don't have to get crazy. This looks like shit. Cycles. I guess maybe we want to turn like the world's color off for this. Maybe a little bit, like just like a little less fucking uber bright. Oh, and then he looks like shit because I turned off specular reflection. That would do it. So this has to come back up. Like this. There we go. That looks like a guy. What do I want this to look like? Yeah, fuck it. Good enough. Again, we are short on time, so we don't have to get crazy. Let's just kind of make something that looks not like total shit. Boom, boom, ba-doom, boom, boom, ba-doom, boom. Do you guys want to see my water bottle? Instead of a cup, I just fill up an old piece of garbage and use that. What's the problem? Okay, here, look, check out our... Ew, dude, that's like fucking cursed. That's fucking awful. I don't like looking at this. But so this should be good enough. Let's just like eyeball it again. EV, turn off specular reflection, turn off all our lights. So now this is what it would look like if we were to just import our guy with the texture that we made. But if we use the baked texture, look at that. It looks kind of good. It looks kind of good. You just gave 18 people some ancient curse. Yeah, dude. Let's. So I think this is what I expect it to look like if we import this texture and just use it kind of like the dumbest way we can. Which is probably sufficient. So can we save this? How do I know who I want to take. How do I save this? Open. Save Blender. How do I save the fucking picture? Image. Here we go. Save as. So, since we're how far are you in the graphics stack now? We've been working mostly on like a Wayland client, so we haven't got too crazy. I think after we finish our little like Wayland client with OpenGL acceleration, then we'll probably flip back onto like trying to write a 2D graphics driver. I think will probably be the next step. So we're not really that deep, but we're having fun, which is all that matters. Let's make a new folder for GLFW Suzanne demo or something. I think Suzanne is the name of the monkey, if I remember correctly. Otherwise, I've just given her a name, and that's kind of messed up. Then we want to export our Suzanne. Oh, fuck. Don't color in. Don't color in. Bad. I know who I want to take me home. Okay, so let's export a OBJ file, because I think that those are really fucking easy to parse. If I remember correctly, what I call this? Glyphwa Suzanne demo. And coordinate space. Up axis Y, forward axis negative Z. Sure. Geometry, I want the UV for sure. Normals, I don't really care about. I don't care about materials. Then everything else is probably fine. Probably fine. If I have PTSD from running a Wayland client, it's kind of fun. I'm having fun. Okay. Okay, so if we want to go to GLFW, Suzanne demo. Let's just make sure that like this looks reasonable. So here we have like vertices in 3D normalized space, followed by texture vertices, and then face definitions. And these face definitions have, each face has a I think it's vertex ID as well as texture ID. So getting these into OpenGL should be pretty easy. Pretty easy. I don't remember what S means. Smooth shading. Oh yeah, okay. So I just don't give a shit. We'll just ignore that. It was cool when I actually got my image on screen, but starting with zero knowledge, it was hard to find good examples. Yeah, that's fair. We found a pretty good one off rip. This like Wayland from scratch. This guy wrote a pretty good blog on it. And then also like the Wayland, I didn't really find this easily. Somebody linked it to me, but just like the official spec. This thing's pretty good too. This, like chapter 4 here, this gave us some pretty nice boom. And then the Wayland book, also pretty good. Okay. We have to focus. I know it's happy hour, but we have to focus. Because I'm hoping we can really just rip this thing out. So where did we use GLFW last? Probably in the video editor. This is probably, no, not the video editor. It was the maps. Maps was the last place to use it. Okay, so what's in here? We want ZLS, we want Zig, we want GDB and Python probably. We don't need expat. We don't need any of this like HTML shit. Perf is fine, GLFW is fine. We know Wayland we probably also need for GLFW to work properly, package config, and we don't need this stuff, okay. All right. Boom, 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 boom. All right. So we need, I guess we probably just copy like our GLFW initialization from here. Yeah, we'll start with this. We'll start here. We will start here. Okay, and then we need to build. So pub function build. B is a stud build. We have const std is equal to import std. We do. B add executable. He comes from, I guess we can't call him Suzanne. What do we call this? GLFW Suzanne demo. And his root source file is b path source main zig. First time chat, Sphera for you. You got me. Optimize equals to opt and target equal target. We parse our target options by saying, well, we want some standard target options for sure. So const target is this, and opt is the standard optimize options. And then we have to install this thing. Caught. Yeah. So b dot install artifact of the executable. Wow. So this is going to try to compile. It's going to fail. It's going to fail because we just copy pasted an existing file. So let's try to get in there and kind of just delete stuff from this until it looks like it's going to work good. So we do need to link. I think we want to use GLFW and then probably GL directly. So we probably want to include like a gl.h and glx.h with a c define of glx prototype? Is that what we found yesterday? It's something like this. We'll find it in a second. Which will mean that we should have everything we need to get moving and grooving. We'll see though. Error callback, this is used in GLFW set error callback, and then GL debug callback. We probably want both these things. Compile link program is going to look different. I guess this is just, it creates a vertex shader and a fragment shader. This is going to look almost the same. This stuff is like bindings for the map stuff, so fuck all this stuff. This all gets out of here. All of this stuff is like maps specific stuff. GLFW wrapper, what does he do? We probably want some of this for now, so I'm gonna leave it. I'm gonna leave that in. Because I don't really want, I want to reduce the amount that we're nuking from here, just up front initially. We'll fix it later. I guess we can leave this in for a bit. More map specific stuff. That is a low effort chat message. Yeah, that's true. Okay, so we have some arguments. Sure, we can leave that in. He gets GLFW up and running. He sets some GL params, enables GL debug. And then here we should be pretty free to do whatever we want. So we'll probably just do something that's like, initially to make sure that everything's working, can we just do like a GL clear? Right, so we can just do like GL clear. Okay, it should look something like this, I think. So we want like C color buffer bit or something, and we want to GL clear color to be like 0.1.0, 1.0, 0.0, 1.0 or something. Let's just kind of see if this works. We need to link, we want like libgl, link system library. How does this work? It's a string probably. And then we probably want GLFW. Probably. I don't know. Okay, somebody's still trying to use our like app thing. Sure, so we'll delete this. He wants a string here, not a number. And then he's mad because I tried to import STV image, which is in here. Glad is not here anymore. It's fine. And is it GL color buffer bit? Might be. All right. Seg fault. Cool. Cool. How do we want to bisect? How do we want to bisect? That's seg faults too. Surprising. I assume it's this, right? It has to be GLFW initialization. Oh, I'm gonna have to link libc. I keep forgetting. God damn it. I keep forgetting. Thank you. You are right. I'm always surprised that it's not like a more hard build error. You know? But thank you. That probably is it. I want Zig build and this. All right. Okay. We're chilling. No more crashies. Let's see if we get a window. Okay, yellow window. We're chilling. Okay. So we've got our example. Has a good starting place. So I think what's the easiest next step here? I guess rendering something. I guess we just run it and we try to load Suzanne a little bit. Right? So we can do something like load load object. So we'll load OBJ, and we'll probably have some sort of like OBJ 3D model abstraction, right? So we'll call this like model, and I guess we'll say this, and I guess we could just do like an inline function here, right? Wow, look at us go, and he's gonna come from some path. OBJ path is gonna be like const8, I guess. Oh, random question. Assuming you're on x86 64 Linux, have you tried using our non-LLVM code gen? Should work fine, I think, and it's speedy. I have not tried it because I read somewhere that it didn't have full compatibility. Oh, I did actually try it one time, and some of my unit tests didn't pass. And so I was like, you know what? It's like maybe not quite there yet. Although I think it's probably, I think I just like I didn't really look into it any more than that. I think I was gonna wait till, I think in the last release notes I saw, it was like, maybe you should use this if you're really excited, but like we're not quite there, was what I remember seeing. So I was like, I'll wait till like the release notes say that like I can, like, it's worth trying. But if you're telling me it's worth trying, maybe I'll give it another shot. Okay, so he's gonna have like verts. That may have been when you were on an old release. IRC on Master is now working pretty damn well. I'm on 013. 013 right now, which is the latest release, but not Master. Yeah, okay. I will give it a shot. I want to I'm worried that I'm not gonna get everything I want to get done today. So I'm not gonna try it right this second. 3chain may have trouble. Yeah, okay, that's what I remember seeing. I'm down to give it a shot on 14 release. I'm pretty stoked on the 14 release, actually. There's like been a few things in there. I'm like, that'll be nice. So each vertex, I guess we'll just kind of say this is a bunch of floats. And we'll say grouped in threes for now. Fuck it. And the faces will be a bunch of indexes into the vertices. So this is going to be grouped in threes, indexes into vertices. Okay. So all we should have to do is now like open the file and parse it. Well, if the stars align, then you should be able to use incremental compilation once we release 14. Hell yeah, dude. Hell yeah. Okay, so we need to open the file. Open file with obj path. And I don't give a fuck arguments. Okay. And then we are basically just gonna rip this thing. So we're just gonna like look for vertices. I guess we probably want to like buff read this and do like some sort of like line split, which I assume that we can do, but I'm actually not sure. Zig standard library. I don't know if I can only split on lines for like a thing in memory or if it is as like a reader thing as well. Probably want like std.io. IO. Like, is there some sort of like, like, does this thing give me just kind of like read? Maybe not. I guess I'll just read it all to one, like read it all at once then, cause like fuck it. Then we'll see. Just reminding you in case you forgot, runs I guess you spawn on a web server and browser and use the docs locally. Yeah, I mean, I'm okay with just doing it online. It's more just I don't really feel the need for it. Read to end alloc, and we'll limit the file size to like, I don't know, a few megs. Data. So then we need an allocator here. Then we're gonna like rip the data. So std mem split scalar, and we're gonna be like, I'm gonna split this on data with new lines. Okay. while line IT next, we're gonna have some line. And if it starts with a vertex, then we're parsing a vertice. Else, if it starts with an F, we're parsing a face. Parsing a face. And if we're parsing a vertex, I guess that means that we have like some vertices and faces that we're allocating. So var verts is going to be an array list of F32, initialized with our allocator. We, at the end of the block, delete this. I guess at the end of the block, we also have to close the file. And we also have to free our data. Wow. Okay. So if we see a vertex, we're going to do line st. I guess we call this a vert iterator. And we'll do stud mem split scalar again on a space. So I guess we want the line, and we want to split this on spaces. Feels right to me. So we're expecting 3. So for 0 to 3, we just basically push this verts append vert IT next, and we'll just like kind of hard differences on card for crashes. I do not care right now. Fine. Or else return error, not enough verts. Or invalid vert, I guess. Okay, and then if we would then want to assert, I guess not assert, but if verts next, we'll say that we are surprised. We are surprised. So we'll say stud log warn unexpected 4th vertex. Vertex dimension. That would be unexpected for a 3D vertice. 3D vertex, I guess. Okay, and then we do the same thing for faces. But we are now... Hold on. We are only trying to look at things up until the first slash. We're trying to look at something up to the first slash. So we're gonna... This is the face iterator. And within our face... Oh, so we expect a face to be composed of 3... Oh, this is composed of 4. Can we re-export this with triangulated vertices? Or triangulated faces? That's gonna make our lives way easier. Way fucking easier, dude. Triangulate. There we go. Much better. Much better. Much better. Man, this song brings back my teenage Top phase. What's Top? Is Top the band? Oh, 21 Pilots. Yeah. They were the fucking bomb back then. Okay. So we are expecting 3 vertices, and or 3 vertices per face. So here we'll be like, if unexpected, we say, I guess this is an error. We know that this is a thing that we don't handle, and we'll just say faces should be triangulated. Not error non-triangulated mesh. This is not And here, for each face, then we need to iterate. I guess we'll parse the textures as well. So do we want to allocate this as like, this is going to be an element buffer, and our input is going to be vertices with I think we want to say grouped in 5s for vertices. Does that make sense? No, I don't think so. Hold on. What's the format again? Because each vertex is kind of like a 3D position, but the way that this is going to like end up in OpenGL world is that each vertex is going to have a texture coordinate, I would have thought. Because you kind of work on vertexes in the OpenGL world, but I guess what we'll do is we will just duplicate the vertex. Yeah, maybe that's easier. Might be easier. Because like typically the way I would like lay this out in storage for OpenGL is that you have like X, Y, Z position, and then like UV kind of like sit next to each other as like one element, and then you do that again and again and again and again, and this gets like index like 0, this gets index 1, this gets index 2, right? And then you would basically create like an element buffer that maps the positions in this to like the faces that you want to draw. And I guess that still works if maybe it's not that hard to find this mapping. Right, because essentially another classic, another banger. It's we are only in 2,000 songs that I remember today. So they're all gonna be like, most of them are like, oh, I remember this one. So if we want to turn this into OpenGL format, I'm gonna skip the texture stuff for now, and I'll think about it later. I think probably what I'll do is I'll try to correlate them. I might do something like texture. Yeah, maybe we like find the texture chords and create a mapping somewhere. But for now, we'll draw it flat for now. We will draw it flat for now. So we're going to be like, I want invalid face, we'll say here, if we don't get this. And we're gonna want like component iterator. And we're gonna split this by slashes. There we go. There we go. So component iterator, and then we'll just say that the face is gets a component iterator next, or else return error invalid face vertex. Okay. All right. I guess this is a U32, and I guess we have to parse these things as like strings. This one I don't know a Minecraft parody for, just the Portal parody. Let's go. I guess we actually want like vert string here is this, and then we want const vert is equal to stud format parse int of the string into a U32. No, sorry, this is a parse float. Into an F32 of the vert string. Sure. Then what? I think it's just like this. And then we append the vert. Does it return error? Yeah, it does. I guess really we should like turn the error into something a little bit more reasonable, but whatever, this is fine. That's good enough. So here we'll go const vert id is equal to this. And then we parse this vert id string. We parse this as a vertex id. So stud format parse int u32 vert id s base 10. This should be id, not it. All right. So this should give us a model. Let's do something where we try to like model is equal to model load with alloc from untitled.obj. Gracefully handled, seg faulted, exactly. All right. He's mad because that's scalars need to be scalars. That's a really good point. Really good point. He's mad because I used consts all over the place when I created iterators, and they need to be variables because the internal state changes, which is another good point. So we'll fix those up. No field next in verts. That's true because it should be vert iterator. Just remember, obj faces refer to verts starting at 1, not 0. Okay, thank you. I would have missed that for sure. So we do, first of all, this should be parsing base 10, not base 1, and then -1. Thank you. And then here we need to return a model. Verts is verts to own slice, and faces is faces. Ether2 is fine, I guess. Okay, so he's mad because parse float had an invalid character. Probably because I forgot to skip the first thing. So for both of these, I need to skip the how do I call this? Like the identifier at the beginning of the line. There we go. Okay, so we parsed the object file correctly. We parsed it correctly. I guess I shouldn't just trust you about that OBJ file index thing. Face elements start at 1. Yeah. Okay. Good. Good eye. Good eye. Good eye. Thank you. Thank you. Thank you. Okay. Always trust chat. No. Never trust chat. So now we need to like put these things on the GPU somehow. So if I don't have a model matrix, which I don't yet, I probably want to like space this out so that we are looking at it from a different certain point, right? So if these are positioned at hold on a second. This is Z up, but our export was Y up, which is going to be confusing. Right? When we did this, it had forward axis -Z, up axis Y. So I think that we're going to have to move in Z. I guess we're going to have to do some sort of conversion where we can kind of pretend that this is in a box of -1 to 1, kind of just general, like ish. And we want X and Y lines up. Z doesn't matter because we have no perspective. So I think we're chilling, actually. We just take the model as is, and we upload it. Yeah, we can just do the model as is. That's fine. Rotate the model now. Is it going to spin? Yeah, so I eventually just want it to look something like this, right? Is what I'm eventually going to have. But let's just start by getting like an image up, right? So let's try to upload this thing. Vertex buffers. Okay. This is kind of what I want. No, I don't want advanced data. I just want normal data. Getting started. We're idiots around here. Hello triangle is probably what I want. Where does he? Here he has some vertices. Perfect. This is what I'm looking for. This is what I'm looking for. So let's make a function that's like bind model. I guess we kind of need like an expected way to interact with this thing, which means that we probably need like, maybe it makes sense to start with like a vertex shader. I guess, yeah. I guess we'll start by drawing a triangle with a vertex and fragment shader, and then we can kind of like adapt that to work with the model. I think that's probably the easiest way forward. Uh, so do I have like, dude? Why did my K key just fell off my keyboard? That was weird. Uh, okay. So did I have somewhere in here where we were compile link program? So here we just want to pass in the fragmentator. So e source vertex GLSL, I guess. Do they have their example shaders in here somewhere? Hell yeah. Hell yeah, dude. So this is approximately what I want probably, right? Can we do this and then delete all these fucking new lines and delete this? And we want a 3D input position. I think that is fair. And we are outputting a homogeneous coordinate into the GL position. Also fine. Okay. And their fragment shader also chilling. Yeah, works for me. Works for me. I think I want it to be white. I guess that sounds racist, but I just didn't know what you just don't worry about it. So now we should just be able to like call compile link program, and this should return us a program. So can we just like return program like this? And this I think returns us a GL unit. We were casting them in our example before, because we were kind of using like this. Had like a generic API that was used in both WebGL and native, and so we were using that to like i320 generic. Vec4 apos.10 also works. Yeah, I know, but I copy pasted from them and they did it the other way. we're really just ripping it today. Okay. I guess we also don't need to take this in as like pointer len anymore, because this was again related to C bindings. So I guess we'll do this. This is VS pointer, and this is FS len and FS pointer, like this. Chillin'. Chillin'. We're not doing any checks here, which we probably should eventually. We should get shader IV compile status, but we'll deal with that later if this doesn't work. Okay. So I guess we just call const programs equal compile link program, and we take in embed file of vertex GLSL and embed file fragment GLSL. Okay. Expected type double pointer found single pointer. Oh, really? Oh, because you could compile more than one shader at a time. Sure. Sure. All right. Shaders seem to compile. I guess we don't really know that because we're not really checking the output, which we should do. Do they do that in this somewhere? Yeah. Yeah. So we do var success is a C int. And I guess we'll just kind of check the success for now. But we'll come back for this. If success equals 0, return error vertex shader compile. It's crazy that I made it this far in my other project without doing this, because this seems like a really important piece of the puzzle. But whatever. Okay. Is this failable? It is. And so do we write try down here? We do not. You're the only programming streamer. Whenever I join your stream, I have no clue what you're doing. We are basically trying to make an OpenGL app that looks kind of like this. That does essentially this. Keeps this little monkey head in the center and rotates around it. Hopefully compliment. Well, I think that whenever I watch my shit back, I wish that I had done a better job explaining. That's kind of like my consistent feedback for myself. So, partially a compliment, partially a you're right. Okay, so we have an object file that we processed. We have a bunch of vertices, a bunch of faces. So we now have a vertex shader and fragment shader that I guess we want to test that they work. So can we like draw a triangle? So we need to bind the program, which I don't know if we did here in compiling program. We probably didn't. Yeah, we probably want to do like cgl use program of the program. And we probably want to upload some vertices. So we need like a vertex buffer object. So where does he make one of those? Where does he do that? It was in this page. I swear we saw it here. Did we have a function that we were making for this already? I can't remember. No. We'll say function bind model. I swear I wrote those words already, but whatever. And we are going to take in the model. And we're gonna say let's huck those vertices onto the GPU. So VBO is a C int. We call GL gen buffers to make this into a vertex buffer. And then we have to tell it what type of buffer it is. So cgl bind buffer as a, what is it? GL array buffer VBO. Wow. What is the status of the custom GPU project? We're so far from that. We're so far from that. We've been playing with, we're trying to understand how like graphics works in general. So we've kind of spent the last little bit working on like a Wayland client in the hopes that we'll be able to get like hardware acceleration through OpenGL on that. Once we finish that, I think the next thing I want to work on is writing a 2D accelerated GPU driver. Sorry, not 2D accelerated, a 2D GPU driver. Then from there, we'll make a 3D GPU driver with custom commands, with hardware acceleration. Then from there, I'm hoping to go into like implementation of OpenGL for our custom graphics driver. That's kind of like the approximate roadmap there. Yeah, the Wayland Cloud is related. Okay, yeah, only like kind of like tangentially in that like I want to understand the pieces of the low-level APIs that are required to share graphics buffers between processes, essentially. And then in terms of like making a real custom GPU, that's probably like way down the road. Because like there's a bunch of stuff to do before that, right? Experimenting with like N64 GPU development, if I want to like see how other people have done this in the past, and like writing like a CPU on an FPGA as like a scoped project that is like gets us the knowledge we need, and then like there's like way lots of stuff before we actually like make a GPU. So you're only making a driver and then using existing GPU for acceleration. I want in the near future, I want to basically, yeah, offload to my real graphics card for acceleration, but like figure out what like the driver APIs should be to make that work. Okay. And then, so we bind the buffer. We need to upload the buffer data. So it's like GL buffer data, I think. Yeah, here. So for now, actually, let's start by just uploading a triangle. So we want like size of, I think this is in bytes. I assume so. Size of thing, I'm pretty sure gives you size in bytes. Pretty sure. Yeah, in bytes. So if we want like triangle, we want 3D vertices. So we want like an unknown number of F32s, and I guess in this language it's like this, and we're gonna go, we'll start with like, the top of the triangle is 0.5, 0.5, Z position doesn't matter. And then we're going to go, this is 0 at the top, negative, negative, positive, negative. Right, so this makes a triangle because this is negative 0.5, and this is negative 0.5. I guess, how do we draw this? Negative 0.5, 0.5, 0.5 is kind of what we're doing here. If you want to go lower level than the Wayland, there's EGL. Yep. Understood, understood. We are going to eventually have to get into that. I don't know if you know, but Learn OpenGL is kind of outdated since they don't use the name version of OpenGL available since 4.x, which are far more convenient. No, I did not know there were named versions of these functions. But that's kind of cool. I just Googled how do I use OpenGL one time. And so I always go back here. So can we do size of type of triangle? Does this work? I think I'd rather kind of do it manually. Size of F32 times triangle len feels more like what I want here. And then this probably has to be cast into, maybe that'll cast fine. And then vertices is going to be triangle as a pointer and take static draw. Okay. Then is there anything else to do here? Probably return the buffer object. We probably want CGLU in here. Let's just be a little bit more explicit. Okay. Cool. The main difference is that you have far less GL bind stuff to call. Yeah, that sounds nice. That does sound nice. I'm in kind of... I don't want to take that on right now because I feel like we have limited time today. But that is useful information, for sure. Called direct state access, if you want to Google it later. Thank you. Name buffers and stuff. That sounds great. That sounds great. Okay. So let's bind model. And then we need to set up our vertex array object to kind of like explain how these elements in our buffers are going to be mapped to the inputs to the shader. So they probably do that in here somewhere. Here. Basically this. Do they not have to make a vertex attrib object? I guess if we're kind of bounding every time we use it, then it's fine. Sure. Sure. Okay. So I need to look up these APIs again. I always forget what they are. I think this says like we are enabling. I think this is like an index, and this is enabling that index or something. I can never fucking remember. Specifies the index of the generic attribute to be modified. Which I guess we're just assuming because we wrote layout equals 0 in our vertex buffer. We're assuming that we know that the index is 0. Then we have the size is the number of components per generic attribute. So we write 3 here, which they have done. We specify the type, which is going to, of the data we are passing in, which is a float. And if they are normalized, which is also false. We are not guaranteeing that these are normalized. Here we're taking 3 elements a size of F32, and this is their offset as a pointer into the input, I think. Or is this stride? Index, size, type, normalized, stride. Oh, and then this is offset. Got it. So here we do, how do you do this in Zig? Int, pointer from int, I guess. Yeah, that sounds right. That sounds right. Okay, so now if we call down here GL draw arrays, and we try to draw GL triangles with from index 0 to 3, I think is this. GL draw arrays. What's this link? Direct state access. Sick. Thank you. Thank you. Sounds cool for sure. First and count. So yeah, we want to draw 3 vertices like this. Fuck. So here we get the const VBO is equal to this. And for now, we just discard it. Fix me free. I guess here as well. Nothing. Nothing, nothing, nothing. So that's not good. I was hoping that we would see this. And so now we get the fun part of debugging what we fucking did wrong. What did we fucking do wrong? Oh, RCR is saying the normalized turns it into a normalized float value if it's an integer. I just never understood that because I never read it. Okay. So what am I looking for next? Why the fuck does this do nothing? Why the fuck? We have our debug callback set, right? If we were to do something like fucking brain dead, would we see that somehow? Like just kind of. Oh wait, do we never bind the vertex buffer? It's bound. But do we have to bind it again after the program is there? I can't remember. But we could try that. We could try it. I don't think that we need to, but it's possible. Yeah, not happy there either. Someone else mentioned the VAO. Do we have one of those? I thought they weren't required. But I do not have one. That is true. I mean, we can always make one. I just thought they weren't required. But sure. We can try it. I think in OpenGL 4 plus functions, they're required since some version of OpenGL. Someone else is saying, I don't need them. So we're kind of flip-flopping. Okay. We'll try it. Var val is a cgl uint. 0. We bind that bad boy. And then, is there anything else we have to do for that to work? Bind vertex array. And I guess technically we don't have to do this buffer bind after. Still nothing. Still nothing. I'm missing a piece here. I am missing a piece. Can we try for now? Let's kind of bisect the problem, right? So we can say that set shift width equals 4, tab sock equals 4, expand tab. Oopsies. If we go here and we don't even worry about the input data, right? We say fuck that shit. We can do if can you do like constant GLSL constants, constant array? Can I like make one of those somewhere? Float vec2 float verts vec2 verts equals vec2 And then here I can just do like 0.5, 0.0, 0.5, negative 0.5, negative 0.5, and negative 0.5, 0.5. No, sorry. This. Then can we do like verts gl vertex ID 0.0, 1.0 or something? He's mad because the thing doesn't compile anymore. So I probably fucked this up somehow. Constant vec2 array. How do I fucking... I thought this was allowed. Trailing comment not allowed. Good point, good point. Good point. Okay, so that's fine. We have a triangle if we use these things. So it's related to our like binding of these things. I guess we didn't bind the vertex array here, which could have been related. I did just forget. So can we go back to using a pause 1.0 or something? Okay, there we go. We're back. We're back. I just forgot to bind the vertex array object here. So if we just don't use vows, does it just not work? It does seem that way. It does seem that way. All right. Works for me. I guess we don't need this buffer here. And probably technically we don't need this either. Yeah, there we go. I see. I see. Okay, so let's do function, I guess here we can make the vow as well. So const like buffer pair is an array object and a buffer object, and then we'll create this here. And then we'll do something like this. Do something like this. This moves up here. And then we return VBO is equal to VBO and vow is equal to vow. Okay. So now that's kind of clean. And then we just make sure that we bind buffer as vow here, even though it's not really necessary. He's mad because I actually don't know why he's mad. What? I've never seen this before. Oh, I see. He's because I'm never mind. I'm an idiot. I'm an idiot. Wrong type. There we go. Okay, so now let's try to replace our triangle with our model. So instead of binding this, we're just going to bind model dot verts. Hello? Yeah, I don't know. It's weird that wasn't working. So he's not happy because expected type of C long found U size. So here we need to incast. It worked before because the length of the array must have been a comp time int would be my guess. Expected type any opaque found pointer to const f32 array. I wonder if this just is because it's like a multi-element pointer here. He doesn't like that. I feel like that should work. Oh no, wait. No. I just want to pass the pointer. Never mind. I'm a fucking dumbass. Okay, and then we need to draw as many elements as there are in Suzanne. So we want model.verts.len over 3. Int cast, probably. Close. I mean, you can see like the basic shape in there. Could we use something else than white on yellow? Yeah, sure. There, you happy? You happy? So it looks like we're close. But it's because I'm an idiot, and we're not supposed to draw the vertices directly. We're supposed to draw them as they show up in the faces, right? So here we're actually supposed to do something that's like var ebo and here we bind this as an element buffer. So basically what we want to say is how do I explain this? Okay. So like if I have actually it's probably easiest to look this way. So if I have like a vertex here, right? This vertex is part of 4 faces. So the way that the OBJ file works is it like specifies each of these vertices and then specifies the links between them, right? So this triangle is going to be like this one, and this one, and then the next face is going to be this one, this one, this one. So each vertex has an ID, and so we have to construct faces of these IDs. Now the way OpenGL works is that OpenGL doesn't really have this concept of like faces. Well, it kind of does, but like it's taking like what we did was we just took all of the vertices and said draw these like they're triangles, but they're not. So what I want to do is I want to make an element buffer that says index into the vertices in this order, essentially. So we should be able to be like GL. Is there like an element buffer? Element buffers. I think they have an example somewhere. Element array. Element array buffer or OpenGL. Is that really only in the advanced section? Oh, here they do it. They have it in triangle. Nice. Element buffer object. Let's go, baby. So they create this thing. They bind the data of the indices. And then it's GL draw elements. Right, okay. So we bind this. Then we buffer data. And here we just take in, it's the same shit. Int cast size of faces. I don't know what our index. Oh, here we tell it later what the size is. So we'll say the size of U32 times model faces len, model faces pointer, cgl static draw. And there's nothing else to do here other than here called gl draw elements with triangles still. What are my arguments to gl draw elements? Count, type, and indices. So count is how many faces there are. So model faces len over 3. And then the wait, I'm confused. Count, type. So here we have to double check, but I think a GL unsigned int is fine if we have U32s. And then I think this would be 0. I don't really know. Okay, GL draw elements. Let's look it up. Pretty sure count is the number of vertices, not faces. I'm fairly certain it's the number of elements in the buffer, in the element buffer, right? Number of elements to be rendered. So this is the number of faces that we have. Pointer to location where the indices are stored. Doesn't this use the bound EBO? This doesn't feel right to me. This is not what I've seen before. I guess maybe on null. The last argument specified offset in the EBO. Oh, I see. Sure. Sure, sure, sure. All right, let's see it. GL element buffer. Did I spell it wrong? Element array buffer. Element array buffer. There we go. My bad. That's a lot closer. A lot closer. I think we might have some sort of like inversion of direction here. Right, it feels like a lot of the triangles look kind of flipped from how they should. So I'm just gonna, on a whim in our vertex shader, say invert Y. I'm not really sure about that, but it kind of looks like, no, that doesn't do it. Right, because they're kind of flipped relative to each other, huh? That if we're flipping everything, that does nothing. That's really strange. I actually don't understand what's happening here. Depends on what you mean by face, I guess, but faces over 3 feels sus. So I think that in here, this is just grouped in 3's indices into the vertex array. And these are the vertices. So if we're trying to draw one face. Oh, I see what you mean. You mean it's the number of vertices in the index? Maybe. We could try it. I don't think that's right, but... Oh, no, that does look a lot better. Okay. Right, so draw elements. Oh, I see what you're saying. I misunderstood you. You're right. Because you're saying, like, basically if I have, like, a face that is... If this is, like, yeah, vertex 0, 1, and 2... If I'm using an index buffer, I draw the face as like these 3 things. So if I drew this one triangle, this would be length 3 because I'm using 3 indexes. Right. Good eye. Okay, that's pretty sick. So now, I guess we want to color him in. And it's probably easiest. So the way that the object format is, so they're kind of specifying, they're tying the texture coordinates to the vertex coordinates by the face mapping. So we're gonna have to figure out how to do that here, because like this element buffer is referring to one position in the vertex array, right? And that vertex array now needs to have like elements that like it doesn't know about till we parse the faces. So we could do this like in like 2 ways. One is that we could just say, fuck this element buffer thing. We'll just like iterate the faces on the CPU and construct the vertex buffer manually and just duplicate vertices. I think that's not like a complete, like a crazy abnormal thing to do. Or we could iterate the faces, and then as we iterate the faces, like populate the texture coordinates. So we could maybe, yeah, that's actually not too hard. That's not too hard. So we could group these in 5s, right? And then we could basically, kind of as we hit each vertex, just append 2 zeros. So we want to do like, how do you do this? Is this the best way to do this? No, surely not. I'm just going to write the 0 twice. You need duplicate vertices for positions and UVs don't match. Oh, that's a really good point. I kind of assumed that they would always work together, but I guess they don't. Yeah, you're right. So then in that case, this is gonna just turn into verts. This is gonna turn into like one flat array, I guess. Yeah. So I guess what we'll do for now is we'll do this. we will store them how it is convenient for us here, and then when we bind them, we'll figure it out. So we're gonna look at texture coordinates here. You can have UV discontinuities. I don't know if this model has any, but in general it can happen. Yeah, that makes sense. I'm fine with just duplicating the vertices for now. So we'll do this. So we do UVs, append UV. Okay. And so it means we need a unexpected third UV dimension. Okay. So now we have looked at each of the VT lines, and now we have to the faces now. This is going to be like vert faces, I guess, and we'll have like UV faces underneath. I guess is the easiest way to do this for now. So grouped in threes, indexes into UVs must be same size as vert faces. So then we can iterate these two things in lockstep and pull from these and to create our final vertex buffer. I think that's the easiest way to do this. So then we'll say that we basically do this, do the same thing here, but for UV IDS. And we'll say invalid face vertex is fine. Maybe we'll say like, we'll call this is no vertex. We'll say this is no face vertex. And we'll call this no face UV. Okay. Cool. And then I guess this kind of becomes like we have faces, UV faces and vert faces. So we'll call this UV faces and vert faces. And then here we'll call this vert faces. This has to be vert faces.deinit. That's crazy. Okay, and at the end, we turn this into vert faces here. We can say UVs equals try UVs to own slice. And we do UV faces. Okay. No field, UV is next. 2 yeah, this would be UVIT. Okay. No faces anymore. Right, so this is vert faces now. And we have that same problem again at 300. No. What? Hello? Oh. I'm just an idiot. I'm an idiot. And then 346, same problem. Chillin'. We're back. Everything working. So I think what I want to do now is I just want to use the UV coordinate as, I guess we should git add source and untitled obj and untitled ping and build. We should checkpoint. Zig cache and zig out are both no-goes. And we'll say initial commit lil monkey. There we go. Okay, so what's next? I want to show the UVs. I want to show the UV coordinates for each face. I think that will be the simplest thing to do here. So I guess what we do is we create a new thing here. And we'll say a const vertex buffer. I guess here That's fine, yeah. Var const vertex buffer is going to be a static allocation, I think, of F32s. And this comes from the length of the face length. I think. No. We want model vert faces len. So this is the number of faces that are indexed as well as UV faces. No. This over 3 times 5. That makes more sense. Right? Because we have 3 vertices per face. No, I'm stupid. Yeah. Because this was going A, B, X, Y, Z before was the vertex length. The vertex faces length was iterating X, Y, Z, X, Y, Z, X, Y, Z. And now we're trying to make our things X, Y, Z, U, V. So that's 5 over 3. I think that's right. I think. So now we can go for 0 model vert face it. Can we just do like 4 model vert faces paired with model UV faces? And we'll call this vert UV? No, because these are not actually the same size. We want to iterate like element by element, face by face. So we're going to go from 0 to model vert faces over 3. That makes sense. And we'll say const x is model. We'll say this is the verts. Vert IDs is model.vert faces from I times 3 to I plus 1 times 3. Yeah. Oh no, they are the same length. They are the same length. I'm stupid. These are the same length because each vertex in here has 3. Each of these is a triangle. Each of these is a triangle indexing to both verts and UVs. Yeah. So then we should just do like vertex buffer. So yeah. So we do our const vert. I guess we'll call this in ID, which is different than IDX. Or verts, we'll call it. Yeah. Verts goes from the model verts from vert ID times 3 to vert ID plus 1 times 3. There we go. That feels right. And then the UVs is the UV ID times 2 because the UVs are grouped in 2s, the vertices are grouped in 3s, and this gives us 5 things. So we can say vertex buffer append slice verts and UVs. Which means that even though we know the size of this up front, I'm just gonna fucking make it an array anyway, or array list anyways. Because it's easier for me. Capacity. Okay. And this needs to be tried. And then we'll say that the vertex buffer, we'll just assert here that the vertex buffer items len is equal to what we expect it to be. Okay, there we go. We need to use the allocator here, and then we need to defer vertex buffer to unit. Okay. All right. So now down here, I think we don't need the element buffer anymore. because we're kind of just like inlining our vertices now. And now instead of using the model verts directly, we use our vertex buffer len, vertex buffer pointer, and our this now is going to have to come in two components. So we have 3 elements. The stride is 5 now, and this is offset by 3 times like 12 bytes, I think. We'll see. We shall see. So we'll call this UV, and then we'll have an output vec to UV. In UV, we'll call this, and then we'll say UV is equal to in UV. Then our vertex, our fragment shader, we can like take that as an input, and then we should be able to just do like UVX here, UVY, and that should give us something kind of interesting. We'll see. Allocator. Let's see. Fuck. Pen slice. Should we vec2 at vertex GLSL3? Good eye, good eye. I think that it probably would have still worked, actually. I think that it knows to like auto-convert. But I'm not sure. What's it mad about? A pen slice? Oh, because it's const. No field named len. That's true, because these need items on it now. Okay, he's mad because we hit unreachable code. So the assertion did not work, which is surprising. Because we iterated. Yeah, I'm stupid. Grouped in 3s. So here we want to go, I guess we have to go by index here. So we'll call this a face ID here. And then we'll say const vert IDs. Yes. Yes. I see it now. That looks more reasonable. Should not be over 3. I think there's more. It's more than that. I was indexing the wrong thing. Indexing the wrong thing. So I want to go vert IDs and UV IDs, indexing into model UV faces. So this gives us what? 3 vertex IDs, 3 vertex IDs, and 3 UV IDs. Yes. And so we need to go 4, 0 to 3. We push these things as a pair. I think. So our verts here fuck. So this is verts here, goes from the vert ID verts from the vert ID here. No, I'm missing something. I'm missing something. Aha. Yeah. Here we go. We index this thing as an element here. So this is, God, my poor fucking stupid head. My poor stupid head. I think it's like verts is like X, Y, Z, X, Y, Z, X, Y, Z. This is face ID 0, face ID 1, face ID 2. So we need to go like face ID 0, 1, 2. I guess we'll put them out of order so that we can like picture this. So here, this is our face ID. Here we're going to go 0, 2, 1, for example. So we index into the vert faces at the face ID to get this triple. Yup. Then, for each element we get out of here, this also points to UVs. UV, UV, UV. So that's like this and this. So now we have to figure out we just index this by this, and that gives us the vertex. Right, because this comes in triples. This comes in triples, which means that we should just be able to do model verts at this. No. Oh yeah, so for this, dude, my poor little brain. We have 3 vertices per face. So I think it's like this, actually. Vert ID and UV ID is the face ID times 3. It's a single vertex ID. For each face, no. Dude, my poor little brain. For each face ID, we have 3 vertex IDs. And if we want to take each of those vertex IDs, yeah, each vertex ID has 3 more elements in it. So it was like this. So, yeah, this gives me a vertex ID. Then for each vertex ID, there's 3 coordinates, X, Y, and Z. Ah, yes. So there's another one of these? So then we have vertex is model verts from, Jesus Christ. Can we just store these not as arrays? That will probably make my life just way easier. That will just make this way easier. Because we're not using these directly anymore. So I think I'm just going to do, this is going to be vert, UV. Like, we just need the types to help us. Okay. Then we'll have like a face. And he'll have a vert ID. That comes from, it's like a U32. And a UV ID. This will help me because I'm just too stupid to get otherwise. So now we have faces, UVs, and verts. There we go. When we parse these things, each vertex goes in there. That's fine. Each UV goes into the UV. And then here we just do faces. Our faces, these guys all need the same behavior as well here. So this needs to be a vert, UV, and this faces needs to be a bunch of faces. Okay. So I guess the how we push this stuff changes now. So we do this. And how do we map this now? We kind of need to go XYZ here. So this becomes a function. We'll call this next as float32. Invalid f32, and then we can just return this. Okay. Then here we can do like vert is equal to x is equal to next as f32 vert it y z. That feels right to me. That feels right to me. And then we do verts append vert. Yeah, there we go. And then we do the same thing for UVs here. Okay. Then for faces, we have the same problem. So a face is actually comprised not of one set of these, but 3 of them. There we go. There we go. So then when we parse the faces, we have vert IDs is 3 U32s equals 0, or equals undefined, I guess. UV IDs, and then we have like this iterates by I. Then the rest of this can be fine. It's just like vert IDs I is equal to vert ID, and UV IDs I is equal to UV ID. And then at the end of this, we say try faces append face with vert IDs is equal to vert IDs and UV IDs equal to UV IDs. There we go. That feels right. But this has to be after the 0 to 3. Yeah. Yeah. That's feeling right. That's feeling right. Faces. A face should be 3 vert and 3 UV IDs. Yeah, I think that's right. Okay, then I fucked this. Okay, so now when we're iterating this thing, it should be easier to like extract what we're trying to extract from it. So here we just go for model faces. For 0 to 3, we have some const vert is model verts at face vert ID is I, and UV is model UVs at UV ID is I. And then all we have to do is append a slice of vert X, vert Y, vert Z, UV X, UV Y. Except I guess these should be UV, U, and V, huh? Not X and Y. Oh, they are. X, Y, Z, UV. There we go. We fucking got there. Array list faces. Speak capital F face. Undeclared identifier vert ID 248. True. True. And I guess we need to try UV's append UV here as well. Expression type F32 found some fucking shit. Because I guess these need to be tried. $295. Better. 309. So now this is just the number of faces times 5. Is how many things we expect to get. That's not true. Because a face has 3 of these, so we need 5 per vertex. So times 15. No thing named vert faces. True. So now we are not doing draw elements anymore. We're doing CGL draw arrays. And we need like the number of elements. So this is model faces len times 3, I think. And GL draw arrays is first and count. So it's from 0 onwards. Okay, wait, that's looking pretty promising. That's looking real promising. So if we look at the UV map for this, right, we kind of see these 2 halves. That kind of lines up with a line down the middle here. Oh, no, unless, what are my UV coordinates? I assume they're 0 to 1. The 2 ears are like kind of nearby each other. Here you can see green, green. So the ears being nearby each other here makes sense. I'm not really sure what this like line down the middle here is. I need a depth buffer. Do I? I mean, kind of. Kind of. I'm kind of seeing what I expect to see, I think. Oh, so I guess maybe the line down the middle is like something to do with depth. I guess like how is this wrapped here? So if I like select like these guys in the front, those are all kind of like localized in one spot here. It could be that the UV is like negative, goes negative here. The line is seam from left to right, but I don't think there is a seam from left to right. That's kind of what I'm saying. I think there's no seam in the. These are all positive. These all go in the range 0 to 1 on both X and Y. Right, like from the back of the head? Yep, you're right. I see. These are the back of the head here. Gotcha. Okay, yeah, I agree. Because no depth buffer. Yep. You're right. You are right. You are correct. In which case, I guess it is time for us to enable a depth buffer. GL enable depth testing. Set GL params. We probably don't need a lot of these things, actually, to be honest. They're just kind of here from before. And I think that there should automatically be a depth buffer attached, right? That's not good. GL clear. Yep, true. There we go. And then we're looking at them from the back now. I want to look at them from the front. So can we just do GL depth func? Like, can we do it this way? Or is it the other way? Oh, I guess everything's facing the wrong way. So what we can do instead is we can just flip the forward direction on our exported model. Export OBJ, and we just kind of forward x is positive z. Does that fix it? There we go. There we go. Much better. And I guess there's probably a seam on the top of the head too. Yeah, I see. All right, that's pretty good. That's pretty good. Will there be a VOD for this? Been wanting to learn OpenGL? No, but we have done all of this before. The reason that I'm not doing this on the mainstream is because we've done this before. If you look at the playlist for stream start screen, this playlist has a lot, like 3D perspective, render monkey, custom OpenGL render, lighting and stuff. So this is kind of like the stream intro screen was done kind of by hand in OpenGL. I kind of did all of the projection and matrices and shit by hand as well, because I wanted to figure out like the math behind them. But I would say check this out if you want VODs about this type of shit. This will be archived in Happy Hour as well, but I don't want to be like, you have to pay. Like, you could pay if you want to see a VOD for this later, but you know, there's something similar already. Okay, so next step, I guess, is to try to actually map the texture. But before we do that, I'm gonna go pee. Be right back. Yo, we're back, baby. Okay, so I think the next thing is to open the image. So I guess we pull STB image. I guess we probably get status and say UVs. Oh, this so many deletions because the object file changed. Got it. Okay, what's next? STB image. Oops. Boom, 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 boom. Oopsies. Curl, probably source. Okay. Build zig. We probably want to build. We probably want to build this as a source file, stb implementation. Right, something like this. Oh, it's like this. And I'm fine with default parameters for now. Fuck it. Fuck it. So I guess we say like exe add C source file. And we have files equal to b path of source stb image C. Then in main, we can just do C include stb image, which means that we probably need to add a include path of b path source. Then everyone should be happy. All right. Then we should be able to be like, yo, I want to load that image. stb image.h. Oh, I don't want loadf. Do I actually want loadf? No, I don't. stb outlet, that's what I'm looking for. Boom, boom. C dot const image. This is width, height, and this is the channels. And I think that you don't have to specify desired channels here. So we just want it to always be like RGB or something, right? And then this can be null because we don't need it. And then we have var width c int is equal to 0 and height also equals 0. Okay. What's our texture called on title ping? Okay. Okay. So now we have an image. So maybe we'll kind of wrap this. So this will go in like init. We'll do with a null terminated const u8. We'll give us an image. Probably this could fail, right? This is going to take in the path. We'll have a data as a bunch of U32s. And width is a U size, I guess. Then we will return this as if image equal. We'll say const data U8 is a U8 pointer. Or else. So if this was null, then we can return error failed to open. Okay. Then we'll call this data pointer, I guess. Image. I guess we'll call this image opt, image pointer. Then is width in pixels here? Probably, right? So then we want image U32 is a pointer cast of image pointer. Right? Then we want to return data is equal to image u32 from 0 to width times height. Right? And then the width is int cast of width. So then we should be able to be like, I want an image initialized with untitled thing. Does that compile? Not quite, because can we get a little tricky and say like align 4 here? No. So we'll just do an align cast here. Fuck it. Fuck it. There we go. So now we have an image. We need to bind this to a texture. So create text from image. All right. This probably returns a texture handle. And we want to learn OpenGL textures. Dude, this is from my favorite movie of all time, Fast and Furious 7. What an absolute banger. What an absolute banger movie. GL gen textures, here we go. Var texture is a C GL uint of 0. Okay, C. A sailor went to C. And I guess we need to like bind the data. So essentially this. And when we load this with 3, I think, does this become aligned at 4? Or do I have to write 4 here? Paul Walker Sag. Well, I mean, somewhat. That guy liked to have like sex with children though, right? So like only a little Sag. Sad that we don't get more Fast and Furious movies with Paul Walker. But he didn't really seem like, he kind of like died street racing too, right? It's kind of like, wait, what? I mean, he had like 2 like 16-year-old girlfriends or something. You need to bind unless before you set the texture parameters. That's a good point. That's a good point. Very good point. I was looking at SCV image to figure out what the return format is. Does it document this? Probably at the top. I guess we probably just want to write 4 here then. If we want them to be interleaved with a sane width. There we go. Otherwise, you'd have to pack them as U24s, which would be annoying. We want image width here and image height, which we haven't done yet. So does this stuff... Maybe we just write an A here, then everything kind of cleans itself up. And then we can just take this from image to data pointer. That should probably do what I want. I'm not sure about like the 24-bit versus 32-bit alignment stuff, so if I just put alpha everywhere, then it should be fine. I think. Sure. We now need to implement image height. So this returns a usize. And this is just image width data len over image.width. There we go. Boom. Boom. And then we just return the handle. return texture, and I guess this can't fail for some reason. We're probably not checking failures. We should be. And then shouldn't one of those zeros be GL unsigned byte or some other CPU bound type? I think I always have to look this up. GL text image 2D. Target, level 0, internal format, RGBA, width, height, border 0, format, RGBA, type, unsigned byte, pointer. Yeah, I think it's fine. I think it's fine. Fuck. Height, out. Call it for now. Avoid the collision. Texture not used. So how do I bind the texture? No, I don't want depth testing. I want... Where's the page that I had on textures? Did I just lose it? Here. Sure, I can set these texture wrapping parameters. Fuck it. Whatever, I don't really care. I don't care. Don't I have to active texture somewhere as well? Here. I'm not gonna lie, I still don't really have a good handle on like what this is. We looked it up before. It's something like when you set the uniform for your texture, it's pointing to an activation, and then the activation points to an actual texture object or something. I always forget. So in our shader, we're gonna need like a uniform sampler 2D text. And then can we just do like texture at text UV or something? Something like that. He's mad because this needs to be in cast. Yeah, that's right. Activation is actually called texture unit if you're picky. Got it. Thank you. I like having people here that can just tell me how I'm wrong all the time. It's pretty sick. Oh, Jesus fuck. Dude, that's fucking cursed. Holy fuck. I guess we save this for later, huh? That's a good picture. So what does this mean? We need to look at like how the actual things are mapped here. So if we're seeing an eyeball like up on the top of his head somewhere like over here, right? Right, like this. Oh, that's so fucked. That's so fucked. Maybe upside down? I do get my texture coordinates upside down a lot. If we're like somehow I'm kind of assuming we're looking from the back or from the front, I mean, but I guess we could have fucked that up as well. Yeah, we could just try inverting a couple coordinates and see what happens. Hey, gotta run. Have a good stream. Okay, bye. Thanks for the raid. Syntax FM. Thank you for the raid. SCP has a bool argument for that? No? I was just gonna flip it in the fragment shader. Like if we do this. Hey! That's freaky as fuck still, but intentionally. Okay, yeah, so we just had it flipped vertically. So you're saying that I can go into SCP image? So for those of you who are joining, We are trying to make a quick and dirty demo app where we can just kind of spin around Suzanne, our little Blender monkey, as a way for us to have a demo for when we finish our little Wayland app that we're working on. So we're writing a Wayland client from scratch, which I don't really know what context you guys have or where you guys are from, but Wayland is like this like graphics protocol on Linux. We're kind of trying to understand the GPU stack on Linux top to bottom. So we've been working on like, how do I use dev DRI handles directly to draw stuff in a virtual terminal? How would I write like a graphics driver if I wanted to make one of those, like make a GPU myself? And so this is part of if we are how does Wayland get graphics handles between processes is like a question we're trying to answer. So we're working on this as like a little demo app so that when we finally finish our little Wayland app, we'll have something that we can show off to people. And the idea is, what the fuck am I alt tabbing through? The idea is that we're just going to have something that essentially looks like, you know, essentially like this, where we can like kind of spin around them is what we're kind of working towards. So we've kind of been spending the last few hours. We exported this model. We wrote an obj parser. We set up opengl to pull out the texture and stuff. And so, Jesus, we forgot to set the image parameter. So flip here. Nice. Nice. So I guess it's like this. There we go. Look at him go. That doesn't freak me out in the slightest. Okay, so the next piece is probably trying to get like perspective matrices. So texture. We want to add a perspective matrix. So a matrix. And I think, unless anybody has a better suggestion, these guys in Learn OpenGL have been using, I think, GLM. Like, I just want like something that will like quickly bang me out a perspective matrix. And I think that in here they're like, they have like, you know, these like nice little translation, and most importantly, I saw a perspective in here. I thought. So if I'm just like, I want a fucking perspective matrix and I don't want to think about the math behind it, I saw that there's this library CGLM which wraps it. CGLM. So I think that we can just kind of exit, add CGLM here, and figure out how the fuck to use this thing. So what we're doing right now is we're kind of just taking like the model coordinates and we're using like an orthographic perspective, which I think you can get in Blender somehow. I don't remember how. Maybe here. There's a way to get an orthographic perspective, but I don't remember how to do it. Camera? No. I can't remember. But essentially, like, when things get far away, they get small, and when we get close, they get big, right? What we are basically showing right now is we're taking like the coordinates of the monkey, and we're essentially just like fourth button down from the 3D axis. Yeah, okay. Yeah, so here we're kind of looking at him in our thing, kind of like this, right? So this is like if you took you didn't take like distance into account. You're just like, everything that is 1 meter apart will look 1 meter apart all the time. So we're kind of showing like this, and I want to show something that's more perspective-y, so that when we rotate around, like it'll say. And then we also want it, so our camera right now, I think is kind of like in his head, effectively. It's effectively in his head, and we're kind of just rendering anything that's like within a 1 meter back and forth or something, 0.5 meters back and forth, 1 meter back and forth, which happens to be everything. But we should basically turn this into like a view frustrum, which basically says like, I see things in like a cone, right? I have a field of view, and so like things that are closer are big. And if you just like took that cone and warped it into a box, like you just kind of like took the stuff that's close by and made it like fat, and the stuff that's far away and made it small, that's kind of like what we have to do. And so there's this thing called like a perspective matrix that will apply that transformation for you. With some like fancy box math, right? There's these things called like homogeneous coordinates that make the math around this very easy. You can just do like a 4-dimensional vector, XYZ, some like mathematical element as like the fourth parameter, and you multiply this by this 4x4 matrix, and you end up like kind of translating and scaling and like perspective shifting everything, kind of in like one globbed up mathematical operation. So these like 4x4 matrices are really common. And so we are going to try to use GLM to just grab one of those for us. So we can do something like, I assume it's like CGLM, but I don't actually know. When are you going to compete with NVIDIA? Never. God, no. So this has like an include folder, and in him he has CGLM. So we probably do CGLM slash project. Sounds right to me. Sounds right to me. There we go. And so if we want to construct one of these projection matrices, we just probably want to call glm underscore project, which maps object coordinates to window coordinates, whatever the fuck that means. But, oh no, I want perspective. I want perspective. I know what I'm talking about. Camera, is there like a camera in here? Frustum sounds promising. Can we just search the repo? Cam.h. So we want like CGLM per GLM perspective. And this gives us a field of view. So like, what's like a sane field of view? Like 90? Is this in, we don't know if this is in radians or not. It probably is. So stud math radians to degrees of radians 90. Probably. Then our aspect ratio is, we'll say 1.0 for now. We'll come back to that later. Far, near and far, we want to be like, well, we want things to be, we want to see things like within a centimeter and within like 4 meters or something. And then we are writing this into a destination 4x4 matrix. So this is a vec4. What is like, do they have a type for like mat4? Shit out on me. More like 30, 60, 90 is pretty wide. When I play video games, I play like 90 to 110. Am I crazy? I guess 70 is pretty normal as well. Do they have mat 4x4? Mat4.h is probably what I want. So this is a mat4 dest, but that's not what's being used in the cam function. Unless there's a mat4 in here. Oh, this is kind of fucked up. Can we go back to the actual C function? Oh yeah. Oh. Dude, default. Let's just fucking use GLM perspective default. Oh, maybe mat4 is like a type def. Could be. Yeah, I see. So mat4 is a I see. I see. So can we do like mat is a C GLM mat4? Okay. So where is like the type defined? Where is the type defined? Probably in like vec4? No client attached. I'm confused. I'm confused. I'm confused. Perspective default. Oh, it's not called a GLM mat4. It's just called a mat4. That's why. There we go. All right. So then we should just be able to like, I guess we also want like a C GLM translate to basically move the guy backwards a little bit. I don't know if like we're using like positive is far in Z or close. I don't know that yet, but we'll figure it out. So does he have like a GLM translate? Where does this come from? Not that I could write this one by hand, but you know, matrix transform probably. Is there like a transform in here? Oh, yeah. Can we just search for translate? GLM translate affine. Translated. Okay, so I see. They're taking like a affine seems right. And so here we have GLM translate, and we take a existing matrix and translate it by some vector. I see. So here we want like some identity matrix. Which sounds like this is gonna have it. So this is make a given matrix identity. Sure. Sure. Okay. So we take a matrix. We say, hey, could you make it completely empty? Or not empty, but like it will have no effect. Then we translate our model by some thing. Right? So can we do like C vec 3? What does this look like? Like let's just kind of move it back by a meter. And then we apply perspective, which I'm not sure if we have to do like, we might have to do like var perspective. We might have to do it this way. And then do like a C GLM mat for mul. And then I don't know which way this goes. Because I think usually like it's right to left multiplication. So we probably want like, if we're trying to do mat then perspective, we go this way. I think maybe we'll have to play with it a little bit. And then can we just go back out into mat? Is that allowed? We'll find out. Okay. So then we should be able to like see GL uniform for uniform matrix 4x4 for floating point values probably. probably. It's 4F or 4FV. So what is 4F here? Probably 4FV is what we want. Yeah. So can we, how does this work? How does this work? The commands, these are used to change the value of a uniform variable specified by location using parameters. Wait, hold on. Uniform. I want the matrix one. Here we go. Where is like 4x4? GL uniform matrix 4x4. Where do these come in? Why do these not? It says it exists here, right? Oh, maybe it doesn't. Can I not pass a 4x4 matrix? Oh, it's just named 4? Oh, thank you. Okay, and so now I just need to know what, like, FV? So I just want 4FV. Yeah. So then I need to put this in some uniform, which we don't have yet. So we need to, like, transform is equal to C, GL get uniform location. Given our program, we are looking for a thing at transform, right? Then we apply this, oopsies, to the transform. What is count here? I assume this is 1. We have 1 matrix that we're passing in. Transpose, I don't know. Probably false. I don't know if they have column major or row major. We'll see if it looks fucked and then we'll just try stuff. And then we will pass in the matrix. So in our vertex shader, we will then say that we have some uniform mat 4, probably. First of all, let's just see if that compiles and builds, like everything still works. No, it does not. So for 20 expected type this found that. We can just pointer cast that, right? Or do we just put an ampersand? Let's see if it likes an ampersand here. Yeah, it doesn't like that. So I think we actually want like pointer cast. Just to make him happy. Expected pointer type found this, so then do I do ampersand here? And then here we're at var. Yeah, and then everywhere we use mat here, we just have to pointer cast, which is a little annoying, but we'll live. We'll live. And I guess here we need like ampersand here. Boom, 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 boom. Expected type this, found that. So here we need to. Really? He expects a pointer. Can I put an ampersand here? Is that allowed? And then here, I guess not because this is constant. Var translation is this. Let me do and translation. O/. Perspective also probably just needs to be like. I don't think you need the pointer cast. I'll try removing them in a minute. We'll see. So you think if I just put an ampersand here, it'll like work itself out? It does seem like it's working, huh? It was probably that the const was confusing me a second ago. I'm down to try it like this. And then here, probably this also needs an ampersand here. Expected type this, found that. Oh, so this actually does need a pointer cast, maybe. Okay, and then we need to link against CGLM. All right. All right, all right, all right. Still no, huh? Undefined symbol. Am I fucking stupid? Where is CGLM? Does he tell us how to use it? Build CGLM headers. Does he have like dash -l somewhere? Ah. Seems fine. I don't really see the problem. Yeah, I don't know. Does this have dependencies? Now my options are CGLM and CGLMC. That's not helpful. Header only library. Oh, this is such a pain in my ass. Such a pain in my ass. Like, is this defined in their fucking thing here somewhere? No. So maybe I need GLM as well. Maybe I need to link against like normal GLM. That would make sense. If this is just bindings around normal GLM. That AVX suffix might be related. Maybe see something like this made up thing. Yeah, I suspect that GLM itself might have AVX instructions built in. Like if we go here and we search for that same function. No, okay, I don't know. Do they have... Oi, oi, oi. CGLM headers. I'm confused. Not gonna lie. GLM definitely has AFX SSA version stuff. There was some clue when you searched for it. Yeah, I mean, it didn't look like anything crazy though. Like it was just like we defined this thing, right? It was just like if defined AVX. Oh, here SIMD AVX. And so this is in. Do I need to like include this file then? Include. So maybe we need like. Like, do I just need to do cglm simd avx mat4.h or something? Like, is that what it needs? I guess we can just do, no, we can't even just easily disable it, because he thinks it's defined. So how does NixOS package this thing? He doesn't do anything crazy. It's kind of annoying. You wrote AVD? I did not write AVX, huh? Yeah, I'm not sure. Not sure. We are going to have to... Can I just, like, undef AVX? How does this work? Oh, it's this, probably. And this is probably comes from like common.h or something. I don't know. But we are kind of running out of time here anyways. It is 1:51 and I've been going for like since like 11, so I want to take a 10-minute break before getting into the mainstream stuff. So I think we made pretty good progress on this today, to be honest. I would have liked to make it a little bit farther. But we can call this whip perspective. And if we go back by one, I think it's good progress to go from nothing to this monkey on the screen. That's pretty sick, fucking cool. Pretty fucking cool. So good enough for now. And we can always use this as our shitty little OpenGL demo later anyways, if we still want to try. We can kind of bake our stuff into this. So it would have been nice to get like the kind of rotation stuff working, but it was ambitious. It was ambitious for sure. Okay. So what we are going to be working on the mainstream is trying to continue on with this like OpenGL buffer sharing thing. So yesterday, we were working on this like little example Wayland EGL app. Let's build it real quick. Probably we need to be in the right environment. Wayland client. This little example app. I guess we need to get into our shell. So the idea is that we are working on a Wayland client that does not use libwayland and does all of the like communication with a Wayland compositor manually. And Wayland has support for EGL and EGL has support for Wayland, but both of those guys work through libwayland. So we're trying to figure out how can we work with this. How can we create a hardware accelerated Wayland client without using Wayland EGL bindings? And it should be as simple as using this extension that to the Wayland protocol, which is what they use under the hood, that allows you to send file descriptors that represent GPU buffers over a Unix socket. So we should be able to like basically make a texture, put it in this like file descriptor and send it over. And so yesterday we were kind of like testing that concept. So we have this like really simple test app that if I run test server here and test client, we see the same little rectangle rendered in both processes. These are from two different processes. So we like render this in software in the client. We like create this texture manually. Then we send it over to this other guy. This was broken at the end of stream yesterday. And the fix was this just like one little bug where basically like after we created our texture, we have to flush the GL pipeline or else there's like some sort of like corruption that happens of the buffer and it doesn't really get rendered. So what we're going to be doing today on the mainstream is we're going to be trying to continue on with this work. This is like a sample of, we have a normal EGL Wayland session and we are just like taking a texture and sending it between processes. We kind of want to like keep going down this path. So we want to render something interesting on like something from OpenGL land onto that texture. Then we want to export that texture. Sorry, brain melting. We need to integrate this with the Wayland protocol to do the same thing, right? So we have our little Wayland app, and we want to basically set it up so that we render our like program to this back buffer, or so to a frame buffer, extract that frame buffer, send it over the wire. Anyways, that's what we're gonna see. I think GL flush only issues a flush, and GL finish issues and waits may be relevant. Yeah, I kind of stole it from just like some guy's example code online, so not too sure. So if you want to see us trying to fight with Wayland and multi-process GPU buffers, stick around. Otherwise, thank you for watching. So let's get into our stream start screen. We really need to take this break. cargo run, and we'll call this sharing GPU buffers between processes part 2.